Well, welcome to our OCS Teach video series. My name's Les Folland.
And I'm Genevieve McMahon.
And today we're looking at a particular skill, the skill of designing a fair test that our students use in science all the way through, really from kindergarten. They start talking about it up to year 12. And it's particularly important in our middle school, in year 5 up to year 8. The students do a lot of this. Students love designing experiments, they love conducting experiments. It's always important that they create fair tests when they do.
So Les, what is a fair test? What makes it fair?
A fair test is a test that's going to actually give you the information you need to answer the question that you're investigating. Sometimes we come up with an idea for investigations that produces data, results, but those results actually don't give us a true picture of what's going on. So it's important to learn how. That's what we're going to do today.
So if it's not fair, we can't trust the data.
That's exactly right. We come to conclusions even maybe, but we can't trust that they're the true conclusions. So, for example, I had a student who brought in some seedlings, and they had an idea. They wanted to actually test something they'd heard. And what they'd heard was you could grow seedlings like this just as effectively under fluorescent lights as you could grow them out in the sunlight.
That's a great test.
That's a great test. So they came up with a hypothesis. They thought, yep, I reckon we can do this. And that's the first step. The first step of a fair test is to identify exactly the question you're testing or trying to answer, the question to answer, or a hypothesis you're going to test. So they had one, and it was good. Okay.
So in their case, their hypothesis was we can grow a seedling just as well under fluorescent lights.
That's exactly
under
right.
sunlight.
Yeah. And then they had to come up with a method that would let them actually get some results and data that would answer this question for them. So can you suggest a method for how they could do this?
Well, I guess you could just grow one seedling under fluorescent lights and one outside in the sun.
Excellent. And so you're testing the effect of that
See
on that.
which one grows better. Yeah.
Now, when you're doing an experiment, there's often things that change or can change. And so you need to identify what we call the variables. And there's different kinds of variables. One of those variables you really do want to change. What's the variable you're going to change?
So we want to change what light source they're growing under.
That's great.
Yeah.
So there's one that you will change. And that's called, I'll just put this over here, that's called the independent variable. You're choosing to change it no matter what else happens in that experiment. So the light source is the one we're going to change. Then the student, while they're designing this, they have to decide, well, what are the variables, maybe one variable, sometimes more than one variable, to measure. What do you think your student or this student might want to measure to help them answer this question?
So we might measure how tall the seedlings grow, and even just how healthy they look, the colour, that sort of thing. Yep,
so we can make some measurements and some observations of some different variables. We call those ones dependent variables. We're seeing if these variables depend on this one. Changing this one, will that actually change these? That's
and
what
we
we're
could
trying
have
to
any number of dependent variables.
We can. Often you try to drill it down to just one or two, especially in a simple high school kind of science experiment. In the real world, experiments are done that often have many dependent variables. Now there's one more type of variable we haven't talked about yet, and it's really important. They're the variables we don't want to change.
Right, so they're the controlled variables.
That's right. These are the ones to keep the same.
Okay, so like in this experiment, we might make sure they get the same amount of water.
Excellent. Yep.
Make sure they're in the same soil. Make sure we talk to them the same amount.
Play the same music to them.
Some people think that helps.
Yes.
Yeah.
Okay. Well, these variables, I'll just put this in here, they're called the controlled ones. That's the term you used, and that's the correct term. They're the controlled variables. Now, what we're hoping is if we keep them all the same, these controlled variables, and we just change this one in an organised kind of way, we'll be able to measure the effect. And that should give us some information. But sometimes in the real world, like in these two seedlings, for example, there may be some variables we don't know about. We can't control them. Maybe the genetics of one plant it makes it more healthy than the other. Maybe there's something in the soil we're not sure about here, we don't know about. So one of the things that we do to increase the validity of our test, and especially the reliability of our test, and to keep it a fair test, is we don't just do one trial. We do more than one trial. So we won't just put one seedling under the fluorescent lights. What could we do?
We could put 10 seedlings under the fluorescent lights, 10 seedlings outside, that sort of thing.
Excellent. Because once we get the data from not just one seedling but 10, on average, we're probably going to see the effect of changing that one variable.
And we can trust that data a lot more than just one seedling that might have its own little problem we don't know about.
Excellent. That's right. So it increases the reliability of our results and therefore the reliability of our conclusions. So if we're going to have a fair test, Gemma, what do we need?
So first we need to identify what we're investigating, make a hypothesis about it. So that's our specific question.
Yep.
Then we need to come up with a method. And then we need to think about our variables. So we are aiming to only change one variable. In this case, that was the light source.
Excellent.
We can measure multiple variables, but it's better if we kind of narrow it down to one or two things we're going to measure. And then all the other variables, we really need to keep the same as much as we can to make sure that it is fair. And just in case, we're going to repeat the trial as many times as we can to make the data more trustworthy.
Excellent.
Does that sound good?
And if our students do that, they really do find themselves getting better and better at producing investigations and data and conclusions they really can trust. So that's how to design a fair test.
There you have it.
Hey, well, thanks for joining us today on OCS Teach Videos.